So we talked about arc length. So if we have an angle in standard position, right? And we said, well, let's say that this arc length, well, let's make a circle here. So say this part of the circle here, this arc that we have, is equal to the radius. Then we said, okay, well, then we'll measure that as 1 radian. This would be the radius, and then they use S for the arc length. So if R is equal to S, then theta, let me give a label to the angle, then theta is equal to 1 radian. But now we have to be able to think of arc lengths in terms of different sized circles, and it's going to be based on the angle, right? And the radius. So you could have like a little teeny circle, and you think about putting a fence around the little circle. That's not going to take as much fence as if you put a fence around the big circle, right? Their circumferences are different, okay? So when we want to find the circumference or a full rotation, so that's like the circumference of the circle. So circumference is equal to 2 pi r. So one rotation is 2 pi r. But now it says find the radian measure of 1/3 of a full rotation. So 1/3 of that's going to be 1/3 of 2 pi r, which is going to be 2 pi r over 3. Okay? But now they want us to find the radian measure. Okay? So what we're going to have to do is take that length and divide it by r. So we're going to have 2 pi r over 3 r. Okay? So the radian measure is going to be, the r's are going to cancel. So you have 2 pi over 3. And now that's in radians. We're not going to write the word radians. We're just going to write 2 pi over 3. And that would be then the measurement in radians of 1/3 of the whole rotation. One thing that I didn't give you yet was the arc length. So arc length, there is a formula to find that. And the arc length is S. So S stands for arc length. It's equal to theta times r. But theta has to be measured in radians. So I'll probably mention this again, but that's the formula for arc length.